Hello, my name is Hannah Bailey, and I am a PhD student working with Dr. Hans Stein at the University of Illinois. Today I'll be presenting on the effect of spray-dried plasma on the standardized ileal digestibility of crude protein and amino acids in diets based on different ingredient combinations fed to young pigs. Spray-dried plasma, or SDP as I will be referring to it for the duration of this presentation, is a byproduct of the animal industry and can be from swine, bovine, or poultry origin. SDP is generally included in diets that are fed to newly weaned pigs for 14 days, and the inclusion rate can be between 3 and 10%, but 6% is generally referred to as optimal. Based on a meta-analysis published in 2020, when pigs were fed a diet with SDP for 14 days post-weaning, feed intake increased by approximately 10%, daily gain increased by approximately 20%, and an improvement in feed conversion rate of approximately 3% was observed when compared with pigs fed a diet without SDP. Additionally, SDP has been observed to increase villus height and villus height to crypt depth ratio in the small intestine, and may also reduce intestinal inflammation by decreasing the concentration of pro-inflammatory cytokines present in the intestinal mucosal layer of weaned pigs. This improvement in intestinal health may lead to an increase in the standardized ileal digestibility, or SID as I will be referring to it, of crude protein and amino acids. However, there are no data demonstrating this. To determine the SID of crude protein and amino acids for a specific ingredient, a T cannula is surgically inserted into the distal ileum of the pig, and ileal digesta are collected for 2 days, as shown by the pictures on the left. A nitrogen-free diet must be fed to determine basal endogenous losses of amino acids, which are subtracted from the total ileal outflow of amino acids in calculating the SID value. Taking a look at the graph on the right from Stein et al. 2007, we observed that when basal endogenous losses of amino acids were not taken into account, ileal digestibility of amino acids increased with increasing levels of dietary amino acids. However, when total ileal outflow was corrected for basal endogenous losses of amino acids, the ileal digestibility value was referred to as standardized and was not affected by dietary amino acid levels, as shown by the orange line. Therefore, the SID values determined for ingredients are assumed to be additive in a mixed diet. Additivity of SID values for crude protein or amino acids is assumed during diet formulation. For example, in a diet with corn and soybean meal, the percent inclusion of corn in the diet is multiplied by the percent of SID lysine in corn, which can be found in the NRC. The same calculation is done with soybean meal, and those values are added together to determine the amount of SID lysine in the mixed diet. This calculation can be done because of the assumption that the amount of digestible amino acids in the diet is equal to the sum of the amino acids from the different ingredients in the diet. However, SDP may improve the intestinal health of the pig and the pig's overall health. The improvement in intestinal health may lead to an increase in the SID of amino acids from other ingredients in the diet, and therefore their individual SID values may not be additive. Therefore, it was the hypothesis of this experiment that spray-dried plasma increases the SID of crude protein and amino acids originating from other ingredients in the diets for young pigs, and therefore SID values for ingredients are not additive in these diets. For this experiment, 10 diets were formulated. 4 regional diets were formulated based on ingredients commonly used in the United States, corn and soybean meal, the European Union, corn, soybean meal, wheat, and barley, Canada, wheat, barley, soybean meal, and fermented soybean meal, and Asia, corn, soybean meal, rice, and fermented soybean meal. These 4 regional diets included 0% SDP, and 4 additional diets were formulated by mixing 94% of the regional diet with 6% SDP. A diet with SDP as the sole source of crude protein and amino acids was used to calculate the predicted SID of crude protein and amino acids in the 4 regional diets with SDP. and a nitrogen-free diet was fed to enable the calculation of SID values. 30 barrows were weaned at 21 days of age and fed a common diet with SDP until 35 days of age, when they were all surgically fit with a T cannula in the distal ileum at an average body weight of 9.3 plus or minus 0.63 kilograms. At 39 days of age, all pigs were randomly allotted to a 10 by 3 Yoden square design with 10 diets and 3 experimental periods. Each experimental period was 7 days, with the initial 5 days for adaptation to the diet and ileal digestive collection for 9 hours on day 6 and 7. Now I will move on to present the data from this experiment. First, I will start by setting up the graph. The 4 regional diets are presented on the x-axis and the SID of crude protein on the y-axis in percent. The light blue bars represent the regional diet with 0% SDP, and the dark blue bars represent the regional diet with 6% SDP. There was an interaction between regional diet and level of SCP for the SID of crude protein. The interaction of regional diet and SCP was observed by the increase in the SID of crude protein for the Canada diet with 6% SCP, compared with the Canada diet with no SCP. But the SID of crude protein did not increase when 6% SCP was included in the other regional diet. For the SID of lysine, the light orange bars represent the regional diet with 0% SCP, and the dark orange bars represent the regional diet with 6% SCP. The interaction term was not significant for the SID of lysine, but there was a main effect of SCP. This was observed by the increase in the SID of lysine when 6% SCP was included in the diet regardless of region. There was an interaction between regional diet and level of SCP for the SID of methionine. This was observed by an increase in the SID of methionine in the Canada diet when 6% SCP was included. But this was not the case for the 3 other regional diets when SCP was added. For the SID of threonine, we also observed an interaction between regional diet and SDP, where the SID of threonine increased in the Canada diet when 6% SCP was included. But the SID of threonine was not increased in the other regional diets when 6% SCP was included. Taking a closer look at the effect of 6% inclusion of SCP to the Canada diet on the SID of amino acids. The SID of arginine, histidine, isoleucine, leucine, tryptophan, and valine are presented on this bar graph, with the light blue bars representing the Canada diet with 0% SCP, and the dark blue bars representing the Canada diet with 6% SCP. The SID of these amino acids was increased in the Canada diet with 6% SCP compared with the same diet with no SCP. The Canada diet was a diet with 30% inclusion of wheat and barley, and less than 10% of soybean meal and fermented soybean meal, and no corn was included. This suggests that the inclusion of SCP to this wheat and barley-based diet increased the SID of amino acids of the diet. This observed increase in SID values was not significant for the other regional diets based on corn, soybean meal, or rice, or lesser inclusion levels of wheat and barley. To test the additivity of SID values in the regional diets with 6% SCP, the difference between predicted SID values were subtracted from measured SID values for crude protein and amino acids. The x-axis represents the United States, European Union, and Asia regional diets with 6% SCP, and the y-axis represents the difference between measured and predicted SID values. The positive value signifies a greater measured SID value compared with the predicted. For the European Union diet with 6% SCP, there was a tendency for a greater measured SID of lysine compared with the predicted SID of lysine. However, we observed no significant differences between the measured and predicted SID values for the other amino acids in these 3 regional diets. This suggests that the measured SID of crude protein and amino acids was consistent with predicted values. Therefore, when diets are formulated, values for SID of amino acids determined for individual ingredients in these diets with 6% SCP can be assumed to be additive in the mixed diet. However, we observed the greatest difference in the Canada diet with 6% SCP. The measured SID of crude protein and all amino acids in this diet was greater than the predicted SID values, with a range of 2.7 to 6.7 for the difference. This positive difference means that the measured SID values were greater than the predicted SID values for the Canada diet with 6% SCP. This suggests that for diets based on wheat and barley, SID values determined for ingredients are not additive in diets when 6% SCP is included. However, the addition of 6% SCP to the diet increased the digestibility of amino acids originating from the other ingredients. In conclusion, the addition of 6% SCP to wheat and barley-based diets increases the SID of crude protein and amino acids originating from other ingredients in the diet, and therefore values for SID of crude protein and amino acids determined in individual ingredients are not additive for these diets. SCP may have a greater effect on increasing the SID of amino acids for ingredients that are less digestible, such as wheat and barley, compared with ingredients that have a greater digestibility, such as corn, soybean meal, and rice. However, further research is needed to determine the effect of SCP on other ingredients included in diets fed to young pigs. With that, I would like to thank APC for the financial support and thank those in the Stein Monogastric Nutrition Laboratory for all their support. Additionally, thank you for listening to this virtual presentation, and if you have any questions about this work specifically, I can be reached at hbailey3@illinois.edu. And if you would like to know more about the research conducted in our laboratory, I would encourage you to visit our website at nutrition.ansi.illinois.edu. Thank you.